All right, 11 o'clock on Thursday morning, and I'm going to get started here with classical arithmetic class. This is a new live class meeting, just getting started this week, trying to get through the introductions before Easter break. I know a lot of students can't attend at this time, but the recordings will be available, so I'll plan on continuing having these meetings and going through this content with anyone who shows up, but these lessons will also be available in a recorded video for anyone to study anytime they want. So what we're doing in the mornings is we're taking care of math and sciences in the mornings in live classes. So on Monday morning, we study algebra, then or maybe I'm getting this wrong. Let me just check the schedule real quick. 1 second. Let's see, in the mornings, if I look at the schedule, Tuesday morning, we do modern sciences, Wednesday morning, modern algebra, and then Thursday and Friday morning, we're going to do classical mathematics. So in the mornings, we're going to cover mathematics and modern sciences. So if you're interested in mathematics and modern sciences, it's this 11 o'clock slot. We're going to talk about that, but Thursdays and Fridays, I'd like to talk about classical mathematics. And what I'm going to do today, especially for you students who are here and anyone watching this video, this first class, I'd like to just explain all of this to you. I'd like to explain to you what classical mathematics are. I'd like to talk about why you should be interested in classical mathematics. Because no one else your age is studying these subjects, so why should you bother with this stuff? I'd like to explain why you should, and give you an idea of how to study it, because it's going to be challenging, but it's not difficult. It's not difficult, okay? So let's start with why, right? Why should we do this? I don't know what your interests are. Maybe you're interested in mathematics, maybe you're not. Maybe you're just trying to get the best education you can. Maybe you're just doing what your parents tell you to do, which is good because your parents have experience and they give you good advice. But no matter what it is, when we look at mathematics, there are two different things to think about. One is, what is the minimum, the lowest amount of mathematical studies that we can do in school to get, let's say, a high school diploma, because everybody is going to need a high school diploma. So one group of students, one group of families can say, what's the minimum? What is, we don't like mathematics, we don't care about mathematics. What is the minimum that we have to do to get a high school diploma? And that's what they do. They pursue the minimum. And that's fine, because if you've got other things to do and you have no need of mathematics, you can do that. Then there's others who say, no, we want to go to college. We're planning to have careers that require college studies and things like that. So we're thinking about college admission. We want to get admitted to the best college we can, maybe get scholarships. So we're looking for a challenging math program. Okay, but you're still just dealing with modern mathematics. And then there's another group of families that says, or another group of students that says, we actually want to pursue wisdom. We actually want to be wise. We're not interested in just doing the bare minimum. We're not just worried about college. I mean, college is important, but what do we do after college? That's also important. And just because you get a college degree doesn't mean you have a successful career and happy life. So we want more than that. We're looking for more than just a college degree. We want wisdom itself. We really want to know how to think, and we want to pursue wisdom in every different area, including mathematics. So there's lots of different students, different families, different needs, different interests, and I understand all that, and I respect all that. But I'd like to talk about some of those concerns, especially college admission, because most families have thoughts about college all wrong, and they don't read what colleges write or listen to what colleges say. They have their own ideas about things and they get it wrong. What colleges are looking for are students who love studying. That's what colleges are looking for. I mean, and just think about that. That's what a college is. It's a place where you can study. A university is a place where you can study every subject. You can study math, science, philosophy, history. You can study medicine. You can study laser beams, computers, anything you want, art, photography, dance, music. Any subject you want is available for study at a university. And what universities want are students who want to study. That's what they're looking for. So they're not looking for the kid who's got the minimum requirements, who, would never study if he wasn't made to. That's not what they're looking for. They're looking for the opposite. They're looking for kids who love to study, because that's what the university is for. The universities usually have millions and millions of dollars worth of resources and all kinds of stuff that they have available for students to use. And they're looking for kids who want to use it. They're looking for kids who want to get in a computer lab and work on computer programming and do stuff. They're looking for students who want to dance, because they've got theaters and dance studios and all of the equipment and facilities for all that stuff. They're looking for kids who want to play sports. They've got sports arenas and sports teams, and they're simply looking for students who want to use all the stuff that they have to do great things. And that's what should motivate students to go to college. They want to get to a place where they've got all of these desires and goals and things they want to do, and they want to get to a place that has all of the resources for them to do that stuff. That's what college is for. And the colleges are looking for kids who want to come and use all that stuff and do stuff and study and work together and solve problems and create businesses and all this sort of activity. That's what colleges are looking for. They're looking for excited, energetic, curious students who want to get on campus and get to work with all of this stuff. So that's what they're looking for. And most high school kids are the opposite. They're barely doing their studies. They're complaining about their studies. They're trying to choose the easiest courses. They're not even thinking about their careers, and they're setting themselves up for failure. Colleges are looking for the kids who aren't like that. So when we talk about what we should study, all the different courses, the first thing you should be asking is, what do you want to do with your whole life? What do you want to do with your life? What do you want to be? What kind of work do you want to do? What kind of problems do you want to solve? That's what you should be thinking about. What's your vocation? Why did God make you? What's the purpose of your life? Those are the questions you should be asking as a kid growing up. And then you should be asking, how should I prepare myself to do what I want to do? Right? How should I prepare myself to do what I really love and am interested in and want to do, what I want to work on my whole life every day? And it doesn't matter, I can give you an example from my own life. There was one day where I was listening to the radio in my car when I was like 19 years old. And I was listening to an orchestra, and there's one instrument in the orchestra called a piccolo. Does anybody know what a piccolo is? If you know what a piccolo is, chat it real quick. What is a piccolo? Anybody know what a piccolo is? Maybe not. If you don't know what a piccolo is, I see some of you typing. Yeah, flute thing. That's good enough, right? It's a very small flute. It's about the size of a pencil, very tiny little instrument, and it plays very high notes. And I was listening to this. It was the New York Philharmonic Orchestra, and I was listening to it, and I could hear the piccolo playing as this orchestra was playing. And I was thinking to myself, how does a person become a piccolo player? How does a man become a professional piccolo player, right? Okay. So Xavier says he learned about the piccolo from the Three Stooges. All right, well, whatever. But what happened was, I was listening to the orchestra, and I was thinking about the man in the orchestra who's playing the piccolo. And I was thinking, how did he ever come to the point in his life where he decided that he was going to be a professional piccolo player, right? And have a job, like have a career, get paid to play the piccolo. What a weird thing to think about, right? But as I was thinking about it, I thought to myself, the reason why he could do that was because he knew that he could be the best piccolo player anywhere. He could be the best piccolo player. And if you're a piccolo player, you're never going to have a job. But if you're the best piccolo player, then you can find a job, because there's a place where the best piccolo player is needed, and that person can have a job doing what they love, just playing the piccolo. And that, for me, that was a lesson for my life, because I realized that I could do what I wanted to do in my life. I could pursue what I loved in my life. I could spend my whole life doing what I love to do in my life, but I had to be the best at it. If I was going to do it, I had to be the best at it. Just like that piccolo player. I wanted to spend my life studying classical languages and the Bible and history. I wanted to do it full time, my whole life, with no distractions. That's what I wanted to do. And I knew that I could do it if I became the best at it. And so I made it my goal when I was like 20 years old to become the best that I could be at classical studies, so I could do it for my whole life, because it's what I love. And I'm not saying that you should love what I love, but you're going to have your own interests. And what I want you to understand is, if you want to devote your whole life to doing what you love, you have to work to be the best at it. You have to commit to it and make yourself an expert in it. So what does this have to do with mathematics? Well, in order to be the best at anything, you have to manage a couple of different things. Not only do you have to do the skill itself that you're interested in, but you have to find a way to provide for yourself so that you can do it. You have to find a way to make a living. And so what happens is, you have a specific interest, like you like to play the piccolo, or you like to paint, or you like to sing, or you like to study a certain kind of literature or something like that. You like to work with computers, whatever. There's your passion for what you love to do, which you can pursue for your whole life. But then there's a need to be responsible and provide yourself, and that becomes the hard part. The hard part is figuring out how to actually provide for your life. And so you have to interact with other people and with business and with the market and all these kinds of things that you're not really interested in, but it's necessary to deal with those things. Unless, of course, you choose religious life, where religious life sort of provides for your basic needs, and then often within your religious life, you can pursue your interests, like studying and things like that. But normally, if you're in the world, if you're secular, you're going to have to find a way to make a living and do what you love. And it's very rare for people to do both together. So you've always got to keep this responsible thought about, college and degrees and jobs and things like that, business. You've got to know how to do both. The specific thing that you love, and also the ugly, ordinary, everyday work of how to actually provide for yourself so you can do it. That's the challenge. Like for me, I'm a classicist, but I had to learn how to build websites. I have to learn how to run a business, all these kinds of things. And I had to learn them so that I could do what I love, which is study classical literature and scriptures and things like that. So you've got to have this balance, and that's the challenge. So when you look at your studies, it doesn't really matter what you're interested in. That's just a part of it. You've also got to keep yourself well-rounded, as they say, so that you can handle these, because you've got to deal with other people and business and all this stuff, and it's constantly changing and not in your control. So when it comes to mathematics, we look at mathematics and we see modern school mathematics, we see arithmetic and algebra, and you get into geometry and then maybe trigonometry or something like that in high school. That's the minimum requirement. That's not the maximum. That's not what the smartest people would do. That's the minimum requirement. That's what everybody does. Every kid who's in high school does that. Now, remember, the piccolo player, in order to be the piccolo player, he had to be the best piccolo player. That's what you've got to keep in mind. To do what you want to do in life, to do what you love, you've got to be the best. And so you're going to have to learn how to succeed at each different level, especially when there are things to do that you're not necessarily interested in, but they're necessary for your long-term goals. That's the challenge in life. Most people will talk about having an interest or talk about having a passion for something, but then when the time comes to do the work to earn the opportunity to do that, they choose not to do the work and they never do it. That's just how it is. So when it comes to our math studies, for example, we can choose to take the ordinary high school course, do the minimum that's required, and when we do that, we make ourselves average. We're just like everybody else. And so when it's time to apply to college or something like that, and we're asked what we've studied in high school, we present an average course of studies. And that says something about, our interest in studying. We've done what was required of us. We've done the bare minimum. We've done what everybody else does. And so we give ourselves a disadvantage because we present ourselves as just average, and we shouldn't want to do that. So when we look and we ask, well, if we didn't want to be average, what would we do, right? What would we do if we didn't want to be average? And what most kids do in modern schools is they just try to stick on all different kind of modern math studies. So they try to study calculus, or they go to some nerdy math camp or something like that, but they're all just doing the same thing. It's just more and more and more of the same thing. They're really not adding anything to their studies. They're just doing more and more of the same thing, or they're adding lots and lots of busy work to what they're already doing, which really isn't going to help them. And other kids are doing the same thing, so it's really not distinguishing them as having anything unique to offer to the community. They're just the same as everybody else. So it's more of the same thing. Now, let's think about it. If we were to think about mathematics, there are individual men in history who were responsible for the development of modern mathematics. So when you hear of a science like calculus, you should ask yourself, where in the world did calculus come from? And when you study the history of mathematics, you find that there was a guy or a couple of guys who actually invented calculus. Well, that's how in the world could they invent calculus, right? They didn't just study calculus. They didn't, get a calculus book. They actually wrote the calculus book. They figured it out for the first time. And when you think about that, it's pretty amazing to think that this stuff was invented by men who didn't have it when they were growing up. They invented it. They invented calculus. They invented trigonometry. They invented these studies, invented algebra, and so on. So we see there's two different kinds of people here. There's two different kinds of people. There are people who study what's already available. That's one kind of person. There are people who use the solutions that have already been made by other people. And then there are people who create the solutions. There are people who actually create the sciences and develop the sciences. So we're talking about two different kinds of people. And if I were to ask you, which of those two kinds of people do you think are the smarter and the greater kind of people? It would be the people who actually solve problems and create solutions. They're the really amazing people in history. They're the most influential and most amazing people in history. And so if we're talking about mathematics, and I asked you the question, how do you think they studied mathematics? Do you think they studied mathematics like modern high school kids? No, they didn't study math like that. So they didn't study math the way that the high schools teach math or the way high school students study math. That's not how the masters studied math. So we have to ask, how did they study math to become masters like that, to become men who could actually invent new mathematical sciences? It's a totally different mind. And when we go back and we find these people like Leonard Euler in algebra, and there's a man named Leibniz in calculus, we look at these people and we say, how did they study it? We find out that most of them actually had a classical education. They weren't raised in modern math classes or used modern textbooks and things like that. They had a classical education, and mathematics was the love of their life. It was their passion. It was what they devoted their whole life to. And they took that classical education that they had, that developed them as people, as individuals, and they applied it to their interest, which was their passion in life. And that's what leads to these great discoveries. That happens in every area of life. If you look at, any great inventors or any great developments or solutions to problems, what you'll find is that there's usually one person who devotes his whole life to that thing, and he's got a unique background with unique opportunities Those are the kinds of people who come up with these solutions. A good example today is Elon Musk with all of his work with electric cars and rockets and all this kind of stuff. If you go back and study the life of Elon Musk, you'll find that he's not like, or he wasn't like a normal high school kid. He was raised different. He was taught different things, and he knew what he wanted to pursue in his life, and he pursued it with all of his might, with no distractions. And today we see the fruits of a person living like that as we watch his life, where he invents and discovers all these crazy things. So we see a couple living examples of this today. And there are a lot of smaller, less popular examples of people like that, doing really great, important things in all their own different areas and interests. But they usually have this same character. They're interested in things not to just check the boxes and get minimum requirements done, but they have a passion in their life that they want to devote themselves to, and they've got to become the best at it so they can actually enjoy it for their whole life. Now, the reason why I'm talking about all this stuff is because when it comes to our studies, we can't ask, well, what are the high school kids doing? What are the other kids doing? What are my cousins doing? It doesn't matter, because that produces average education. That makes you average. That's not going to help you. What you've got to ask is, what studies are going to allow me to pursue higher things in the future and prepare me to pursue what I'm really interested in a responsible way, and give me the skills and the thinking skills and the knowledge that I'm going to need to do those things. That's what I actually need to know. And if you have that spirit, if you have that attitude and spirit, that's the kind of attitude and spirit that the best colleges and universities are looking for. They know what to look for, but no kids choose to live like that. So they often end up taking lots of average kids just to fill spots. But they're looking for kids who devote themselves to greater things and who want to do greater things. There's just no kids who do that. So they're stuck taking average kids. But when we talk about mathematics, I don't think you should do just the normal high school studies, because that just leaves you average. It doesn't prepare you to be a problem solver. And for all the talk, if you do study like that, you're going to find it's pretty boring studying modern math. You're just told, all right, here's the rule, step 1, step 2, step 3. Here's 20 exercises, take the rule, do the exercises, turn in your assignment. You really think that that's mathematics? You really think that that's what motivated men like Euler and all of these mathematicians to invent mathematical sciences and think? No, obviously not, right? That's not what motivates mathematicians. Real mathematicians are motivated to solve problems. They've got real life problems they want to figure out. That's what motivates them to study math. For example, Isaac Newton, you've probably heard his name. He's a great scientist. Isaac Newton was a physicist. He studied physics. He was trying to solve science problems. And what he found as he was pursuing his interest, which was science, he found that the mathematics that he knew didn't allow him to solve the physics problems. The math wasn't strong enough for the problems. And so he couldn't solve the physics problems because the math wasn't good enough for it. So he had to invent calculus as a mathematical science and then use calculus for his science studies. So he actually had to invent a whole mathematical science just so that he could continue in his science studies. That's what motivates people to do mathematics. It's not mathematics itself. It's that they're trying to do other things, and mathematics is a part of what they need to do to solve the problems that they're interested in, whether it's science or music, or, if you're interested in cars or computers. Eventually you get to this point where some study that you need for what you're doing isn't good enough, and you've got to create your own solution. That's what motivates mathematicians. They want to solve problems in real life, in the military, in politics, in technology, in music, in art, in dance, whatever. They're trying to solve problems, and that leads them to have to find solutions in other areas as well. It's not by studying modern math classes. That's boring. You know that's boring. So when we look at mathematics, we look at classical mathematics, which is what I want to talk about here. We look at classical mathematics and we say, why should we study this? Why should we study classical mathematics? And I'll talk about what it actually is in a minute. Why should we study this stuff, right? Why shouldn't you just do the normal course of studies and try to get good grades? Isn't that the best thing to do? No, because that makes you average, okay? That's not the best thing to do. Should you do that? Yes, you should study modern mathematics and you should try to get the highest possible grades because that's what a great person would do. A great person, if you're smart, you should be able to get good grades in math. So there's no excuse for that. But you've got to look beyond that and ask, what should I study? I shouldn't limit my studies to modern math classes. What should I study in addition to that? And classical mathematics is a good answer to that question. So the reason why you should study classical mathematics is it will give you a deeper understanding of quantity. And I'm going to talk about this. So I don't want it to sound philosophical because that gets boring, but the real issue with mathematics is that we have to answer questions about quantity, about numbers, about measures and things like that. Our life is we live in time and space. You know, we're physical creatures. I can only travel so far. I can only move so fast. I can only carry so much. I'm limited by mathematical realities, and I've got to study those things because there are a lot of things that I want to do, but there are only so many things that I can do. And a lot of the things that I want to do, the problem is I can't move fast enough or lift a heavy enough thing or last long enough to do what I want to do. And that becomes a challenge. So part of the solution is figuring out how to actually do things. That's where mathematics comes in, right? We have to figure out how to actually do things. So for example, if I want to grow a field full of corn, I can't go out there with a hoe and a rake and grow a field of corn because there's not enough time. I don't have enough strength and I won't be able to get it done. So I've got to first, instead of trying to figure out how to plant the field full of corn, it would be better if I spent my time trying to invent a machine that could plow that field and allow me to plow that whole field in one day. And then maybe I can devote my time to inventing another machine that would allow me to plant the seed in that field. And then maybe I can invent a chemical that I could use to spray to kill the weeds. And you can see how human nature, because we're intelligent creatures, our strength is not actually our physical strength. Our strength is actually our intelligence. And we can invent tools and invent machines and invent sciences that allow us to do infinitely more than we can do with our bodies alone. So the strength of a human person is actually their intelligence. And you're going to accomplish more through intelligence than you are through physical strength. My sons love to lift weights. They're big, strong, muscular kids. And I always criticize them and I say, I can lift a lot more than you can because I have equipment and machines. So I don't really care how strong your arms and legs are. If there's something big and heavy that needs to be moved, wimpy dad who sits at his desk and studies can lift a lot more than you can because I have a machine, right? And so we can accomplish more by our minds and intelligence and human intelligence than we can with our bodies. If I want to move fast, you know, Usain Bolt is an Olympic sprinter. He runs very fast, but if I want to move fast, I have a car. I'm a lot faster than Usain Bolt once I get in my car. And so you can see how human beings invent all kinds of solutions to problems that allow them to do much more than they can do physically because their intelligence is so much more powerful than their physical bodies. And that's where mathematics comes in. It allows us to do much more than we can do physically. So there's no limit really to our intelligence because we can simply develop things. We can develop things that allow us to do far more than we can with our natural bodies. So our intelligence is more important. So when we talk about mathematics, mathematics is usually the key that unlocks a lot of these doors and gives human beings the ability to do things that physically by themselves they wouldn't be able to do. And it's not just for things like traveling into space and stuff like that. It's just all kinds of everyday ordinary life, using computers, developing solutions to problems, coming up with business plans. Mathematics is the means by which we are able to figure out how to do things far greater than we could do just by our own natural abilities. So it's a strength that we have. And when we think about how it should be studied, modern math classes aren't enough. So we want to understand quantity. We want to understand all of the characteristics of number and quantity and measures and figures and all these sorts of things so that we can use them to solve problems in the future, solve problems in our lives, and have a real mastery of the subject of quantity. That's the real issue here, quantity, because we're limited to time and space, and therefore quantity becomes very important. Quantity is not important for God. God doesn't have to think about how much time is there in the day to work, or how much can I actually carry, or how long can I do this for before I run out of energy. God doesn't need to think like that. God simply has to will something, and there's no limit to the power or time or anything else that he has to work with. We, on the other hand, are not, we're the opposite. We're entirely limited by physical things. And so quantity, our relationship to quantity becomes very, very important. And anything that we do is going to force us to face the limitations of quantity in our life. And I'll give you one Bible verse that I want you to keep in mind about this. One Bible verse, something Jesus actually said. He said, the spirit is willing, but the flesh is weak. The spirit is willing, but the flesh is weak. So we're going to, in our life, we're going to have all kinds of good desires. We're going to have all kinds of dreams and goals and things we'd like to do, because our spirits are like God. They've got no limit. They want to do amazing things. They want to run 1,000 miles an hour. They want to travel through the universe. Our spirits want to fly. They want to do all kinds of amazing things. Our spirit would like to study endlessly and just study and study and study and study and gain infinite knowledge. Our spirit would like to do that. Our spirit would like to help all the poor people in the whole world. We'd like to go everywhere and give everyone food and clothing. Our spirits would like to do that, but we're limited by the actual money or resources or time that we have. So the spirit is willing, and we're always going to have desires for great things, but we're limited by our physical bodies. And so we're always going to have to try to find solutions that take our physical bodies and limitations into consideration. And that's where the study of quantity comes in. We're going to have to always consider quantity as part of the plan. So that's the challenge of real life. The challenge is figuring out how to actually do things with our bodies in the real world with all these limitations. And so we've got people who talk a lot about doing things, but they never do anything. And then people who actually do things, who figure out how to actually do it in the world. All right, let's chill with chat because I want you to stick with me here. So the spirit is willing, the flesh is weak. If we want to do great things, we're going to have to figure out how to do them in the body, in the real world, in the presence of all these limitations. That's the challenge. And mathematics, our knowledge of mathematics, helps us to calculate all of those things and come up with realistic plans that actually work, real solutions that actually work. That's the challenge in every area. So again, don't think I'm talking about launching rockets into space and all this nerdy robotics or computers. In any area of life, any area of life. Let's say you want to be a dancer, right? Like my daughter dances. Well, there's only so many hours of the day that you can practice dancing. And there's only such an amount of time that you can actually dance because it's very physically demanding. So all of these quantity questions start to come in. No matter what it is that you want to do, you're going to have to deal with quantity. So if you gain a real mastery of this subject of quantity, It gives you wisdom that you can then use to find real life solutions and manage your life responsibly. So we have to study quantity. Now, I don't know if you can see it, but on the board behind me, it's not that important if you see it, because I'm going to explain it. But wise men understood all this stuff, and they got to work. And I'm talking ancient 500, 600, 700 BC. Men got to work investigating this subject of quantity to try to understand it because they wanted wisdom. And they studied quantity to try to understand what quantity is and what different kinds of quantity exist, so that they could figure out how to actually study quantity and become masters of this topic. And so what they found as they studied quantity, they said there's two kinds of quantity. There's two kinds of quantity. If you've already studied arithmetic, if you've already studied classical arithmetic a little, who can tell me what the two kinds of quantity are? There's two kinds of quantity. Anybody know what they are? They both start with the letter M. What are the two kinds of quantity? Does anybody know? If you don't know, you can just type no. So I know you're not going to answer. If you don't know, just type no. If you do know, what are the two types of quantity? They start with M. Okay, good. Blaze, multitude and magnitude. Very good. So the two types of quantity that the ancient wise men identified were multitude and magnitude. They said, though there's all kinds of quantities, all kinds of numbers, measures, all this stuff, there's only two kinds. There are multitudes and there are magnitudes. Okay, good. Yeah, multitude, magnitude. A multitude is a group of disconnected things. A multitude is a group of disconnected things, what we would call a number. That's a multitude. So if you see a pile of rocks, that's a multitude. If you see a flock of sheep out in the field, that's a multitude, okay? It's a collection of disconnected, separate things, and each of those things is the same. So it's a collection of units. That's what a multitude is, all right? No matter what that is, it could be sheep, like I said, it could be quarters, it could be rocks, whatever, a multitude of people. A multitude is one kind of quantity. So we've got to study multitudes. We've got to learn about multitudes and become masters of multitudes so that we can use this knowledge to do things with quantity. The other kind of quantity is magnitude. Magnitude is a single thing. So rather than a collection of things, a magnitude is one thing, but it refers to the size of that one thing, okay? So we could have a multitude of sheep out in a field, and we could say there's a multitude and they're all the same because they're all sheep. The unit is a sheep and there's a multitude of sheep, okay? But if we were to take each sheep one by one, we would find that the sheep are different. And one way that they're different is they're different in size. We could have an old sheep that's big and we can have a lamb that's small. They're both sheep. They're both counted in the multitude, but they differ in magnitude. Okay, so there's two different kinds of quantity. Multitude, which is measured by number, and magnitude, which is measured by size. So the ancient wise men said, all right, we've got this figured out. There's two kinds of quantity we have to figure out. We have to study and learn about. So then they looked at multitude. And as they started to study multitude, they said, well, I'm noticing that there's two different kinds of multitude, right? There's two different kinds of multitude, okay? There's an absolute multitude, which is just a number. Like if I asked, how many sheep are there in this flock? And you simply count them, 1, 2, 3, 4, and you count. There's 200 sheep in this flock. That's one kind of quantity. It's an absolute multitude. So you count the number absolutely by itself. But what if the neighbor also had a flock of sheep? If the neighbor also had a flock of sheep and I said, wow, we've got 200, but the neighbor has way more than we do. And if we looked at his flock and we said, how many sheep does he have? And we looked at our flock, we could say, I think our neighbor has double the number of sheep that we have. And so we've got a different kind of multitude. We've got an absolute multitude, which is just a number like 200 or whatever I said. Let's say 200. But there's another kind of multitude where it's a multitude where we compare one multitude to another, and we say that multitude is double this multitude. Okay, so that's a different kind of multitude. So we've got absolute multitude, which we measure with number, and then we've got another kind called relative multitude, which we compare by a ratio or a comparison. Okay, so two kinds of multitude. There's absolute and relative. So keep that in mind. We're going to come back to that. So two kinds of multitude, absolute and relative. When we look at magnitudes, these ancient wise men said, well, we're trying to study magnitudes, but we're running into a problem because there's two different kinds of magnitudes. And this makes the study difficult. There's one kind where we can find a thing, and this thing is at rest. It's easy for us to study. It's at rest, like a mountain, right? If we want to measure the size of a mountain, the mountain is at rest. It's easy. We can just, walk around it, count the steps, measure how tall it is, and so on. We can calculate the size of a magnitude at rest. That's simple. But the stars, well, they're different. This is much more complicated. I'd like to know how large the sun is. I'd like to study the magnitude of the sun, but there's a problem. And the problem is that every day when I look at the sun, the size is changing. One day it's big, another day it looks small. The same is true with the moon. One night I go out and there's a giant moon out over the horizon, and then a few hours later it's up in the sky and it's small. What in the world's going on here? How can I measure the magnitude of the moon or the sun when the size is changing all the time? And so what they realized was that there's one study of magnitude when things are at rest, where the size doesn't change. And there's another study of magnitudes when they're in motion and they appear to change. And so there were two separate sciences that were needed, one to study things like a mountain or a field, which doesn't change in size, is at rest, and another to study things that are constantly moving, where the sizes appear to change. So two different kinds of magnitude were identified, magnitudes at rest and magnitudes in motion. So now when we put all that together, what these wise men said was, we've got 4 different things that we need to study. There's 4 different things we need to study. We need to study absolute multitude and learn to number things. And what if there's, fields and fields and fields full of sheep? What are we going to do? We're going to count them one by one? How are we going to possibly do that? It's going to take forever. We'd like to figure out if there are, sort of like tricks that we can use to calculate the numbers and multitude more easily, more quickly. Sometimes we have to calculate great quantities. So we need to learn about absolute multitude and number and understand all that we can understand about that. That's one thing we need to do. We also need to study relative multitude. We need to learn about ratios and relationships. And this gets even more weird because musicians start to realize, I took a string that was 2 feet long and I plucked it and it made a sound. And then I took another string that was 1 foot long and I plucked it and it made a different sound. So the long string made this sound, the short string made this sound. And then I found that if I get a couple different strings at different lengths, if I pluck 2 of them at the same time, it sounds beautiful. There's, this idea of harmony. It sounds like these 2 strings go together when I pluck them together. And then if I pluck 2 different strings, it sounds terrible. And there's something about it that my soul doesn't like. So there's something weird going on here. There's something weird about these different relationships and the ratios between these different measures. So they said, we've got to study absolute multitude and learn how to number things and learn about numbers. And we've also got to learn about ratios and relationships between different numbers, because it seems like they have important effects. We've got to understand ratios and their effects. So the first study they called arithmetic. And the second study, because they actually were focused on music, they called it music. Even though it's a mathematical art, studying relative multitude, studying ratios and relationships, they called it music because that's where they were most concerned about those relationships. So we've got arithmetic, absolute multitude, and music for relative multitude. And then in the other two areas, they said, well, when we study things at rest, we're usually concerned with studying things on the earth. So they called it geometry, which means measurements on the earth or measuring the earth. Geometry is the study of magnitude of things at rest. And then they said, when we're trying to study the magnitude of things in motion, it's usually we're trying to study the sun and the moon and the stars. So they called that astronomy, the study of magnitudes in motion. So they came up with 4 sciences that they realized that they needed to study in order to get this wisdom. They needed to study arithmetic, music, geometry, and astronomy. And those 4 sciences became the 4 ancient mathematical arts, and that's where they came from. And there are no other arts to add to that. It's not like there's 100 others or there's different ones. That's all of the arts that there are, because there are 4 kinds of quantity and no more. There's absolute multitude, relative multitude, magnitude at rest, magnitude in motion. That's it. Those are the 4 kinds. And each of those 4 kinds of quantity has an art or a science where we study that quantity. And that's where the 4 mathematical arts come from. So again, on the board behind me, I have that summarized, but it's pretty easy to understand. And the ancients figured that out, and then they began the study to try to understand these 4 different types of quantity. And so in classical mathematics, we enter into that study. We learn what they were able to figure out. We study what they studied and taught, and it gives us a masterful understanding of this subject of quantity, which is very, very important for our life. That's not taught in modern schools, because modern schools are not trying to give children wisdom or seek the knowledge of philosophy. They're just trying to give kids the bare minimum that's required, because school is really like a mercy ministry. The public schools exist to just give kids a basic education so they don't have so they have something, right? It's not meant to lead them to wisdom. So if you have the opportunity to study, and you're not like some homeless kid who goes to a free public school just to get a basic education, but you have the opportunity to do more, what you should be interested in is the actual study of quantity, which is pursued not by a modern math program, but by classical mathematics. So that's where all of this comes from. That's why you should study it, because if you have any ambitions or goals in life, you're going to run into quantity as a limiting factor that controls what you can and can't do. And so your knowledge of quantity is going to allow you to overcome obstacles and find ways to get things done. So that's where all of this comes from. That's why we need to study classical mathematics. And in this meeting on Thursday mornings, we're going to talk about the first 2. We're going to talk about arithmetic and music, because they're both 2 kinds of multitude. And then on Friday morning, I'm going to teach through the works on magnitude, on geometry and astronomy. So that's what we're going to do. That's where all this stuff comes from. It's not crazy stuff. It's not weird philosophy stuff. It's stuff that you actually run into every day, problems you run into every day, and studying to understand these things so you can find solutions to them. Because again, the spirit is willing. You're going to have all kinds of dreams and desires, but physically, you're going to be limited, and you're going to have to learn to deal with quantity if you're going to do anything in real life. So that's my introduction to classical mathematics, where these 4 different mathematical sciences come from. And those together, the 4 mathematical arts, they're called the Quadrivium. So if you want a fancy word to throw around at birthday parties and impress people, you can use Quadrivium, and everybody will ooh and ah when they hear you use these fancy words. But Quadrivium, I'll type it for you so you can see the word here. The Quadrivium refers to the 4 mathematical arts in classical philosophy, quadrivium, 4 arts, okay? And then in the language arts, we have the trivium, which is the 3 arts, grammar, logic, and rhetoric. So trivium and quadrivium, you have a total of 7 arts. They're called the classical liberal arts. That's how classical philosophy educates its students. That's why I started the Classical Liberal Arts Academy. And anyway, that's an introduction to all this stuff, okay? So I hope that's helpful. That gives us an idea of why we should study this stuff and why it's worth our time. On Thursday and Friday mornings, if you're interested, I'm going to walk through these studies and go through these 4 arts, just taking my time to go through them, talk about each of the topics, and we'll go through at a pace that's comfortable week by week. So if you're interested, you can join me for the live class. If you got other things to do, I still encourage you to study these subjects, but you can watch recorded lessons, so that's fine. So whatever works for you is fine. If there's even 1 or 2 kids here for the live class, I'll keep going. But if nobody shows up, then I'll just start recording the lessons and publishing them. But if you'd like to come and talk through these things live, that'd be great. I would like if you come to live classes. I would like it personally, because when I have to look at students and teach with students looking back at the screen, and you can ask questions and you can interrupt me and things like that, it helps me to go through the study at a pace that I know the students can follow, because I can look at you and ask you questions and make sure you're following me. Where if I make a video by myself, I could just go crazy and run off the rails, and students, won't watch it. So it's helpful for me to be able to work with you guys live, because you know how I ask you questions now and then and things like that. It's good for me to know that you're following me. And if I see that nobody has any clue what I'm talking about, I can take a break and go back and review and explain things. So I think it makes the videos better. So anyway, that's what I'd like to share today. Introduction to the 4 classical mathematical arts, and we'll study them on Thursday and Friday mornings, whether you can make it to the live classes or not. All right. So if you have no questions about anything, you're free to go now. If you do have any questions, I'm happy to hang out and answer those questions. So just chat them to me and we'll stick around in the chat. All right. Thanks for coming. Goodbye, everybody. God bless.